Hi, everybody. Tommy Clayton here, an OpenSciEd middle school teacher and lesson writer. Excited to dig into lesson 10 from the Contact Forces unit, unit 8.1. This is a really cool lesson because this is when students get to put everything together that they've been uncovering. And so I think you're going to see some tremendous growth, and you're going to see a lot of excitement in the students as they figure out that they can go back and explain a lot of those stories and collisions from lesson 1. So let's dig in and check out this lesson. All right, let's remind ourselves how we got here. So we're coming off of lesson 9 where we figured out a lot about friction. We figured out that essentially it's a contact force that works against motion, and that there's like millions and millions of collisions happening with the surface and the air, and those cause energy transfers. So this lesson, we're really wondering like why some objects break or not break in a collision, right? Essentially, like, can we go back and answer all of the big questions we had around cell phones breaking or those stories that we had in lesson 1? All right, so here's this lesson at a glance. This is a putting the pieces together lesson. It's over 2 days. It will take about 20 minutes or so to set up. There is no hands-on investigations, does not require devices, and there is no additional related videos. So on day 1, we're going to navigate in. We're going to create a poster to take stock of all the big ideas that we have figured out and all of the lessons up until this point. We are going to use those ideas to revisit collisions from lesson 1, so those 3 different types of collisions, and work to explain those in small groups. Then we're going to get some feedback from partners on our explanations, and then we're going to navigate out by previewing that we're going to return to the question board and take an assessment next class. And so that's what we do on day 2. We go back to our driving question board and we take an assessment that is all about baseball. All right, so here's what we figure out. We figure out on day 1 that we can explain a lot of our stories, a lot of our collisions that we described from day 1. We can explain why things get damaged or don't get damaged in a collision. On day 2, we figure out that we've made a ton of progress on our driving question board, and we can apply all of these great science ideas around mass and speed and peak forces to things in the game of baseball, like collisions with the bat or collisions with the bat and the air as it flies through the air. All right, so here are some key moments in this lesson. We're going to dig into 2 of them. The first is part 2. So after we've navigated in on day 1 and made a big record of all of the big ideas, we're going to use that to explain a collision. So kids are going to be in groups, and they're going to pick one type of collision to explain. Each student in the group is going to do a different one, and they're going to ultimately explain one of those collisions from early in the unit. And in that third box, they're going to actually think about what could have changed the outcome. So in that story, if they had described a collision where things did not get damaged, they would explain like what they could change about that collision to actually ensure that the object was damaged. So they might say things like, make it go faster, or make something really heavy hit it, whatever the case may be. All right, so after they do that, they get some feedback on that, and then we close out that day, and then on the second day we come in and revisit the driving question board, and then we take this assessment. And so this assessment is going to take most of the class period. There's 30 minutes allotted for this. And students are encouraged to use the Big Ideas poster to help them throughout this assessment. This assessment goes back to things that we covered in the first lesson set. So there are questions that ask students to draw force diagrams. They're drawing a line of best fit. And they're, really digging into ideas around mass and speed and peak forces and energy transfer. And now we have some great questions around like friction and air resistance and those sort of particle collisions. Okay, so here's some tips and tricks for this lesson. If you can, I would try to take a picture of that collisions chart from lesson one where they had all the note cards on it. I think that's much easier for students to work with when they're trying to develop their collisions explanations versus getting up and looking at the poster and having a lot of students crowded around it. I think it's better for them to access that poster in a more individual way, like a handout or an image on the computer. There are two versions of the assessment. Assessment 2 is more challenging. It removes some of the scaffold, so you may have some learners in your classroom that might be appropriate for. That big ideas chart, I actually encouraged my students when they were taking the assessment to mark on the question like which big idea they were using. So maybe they were using, number 2 or number 5. It helped me get a little bit more understanding of their line of thinking, having them take the time to just write that number next to the question. This assessment is long. There are a lot of pages to it. There's some graphs. It looks like a lot. So I used to give this to my students 1 to 2 pages at a time, depending on how the question fell. It can be kind of overwhelming handing this out with, the 8 or so, 9 or so pages. What I did with my students is we read through the whole thing together, and then we looked at those couple of pages that we had, and then had them move on to like the next ones. In the assessment, there is a question. Question number 3 asks the students to design an experiment. And I think it's helpful if students are reminded of some of the class materials we've used throughout. Essentially, we're looking for kids to say things like maybe a fan, maybe the cart, maybe the launcher. So it might be helpful to just have like a class list somewhere or something that can indicate to students like what materials we've used throughout the unit. Questions 11 and 12 are actually subjective. So the evidence and the reasoning is what matters in these answers. And the students can kind of approach those questions in different ways. You'll see in the guidance, it explains how to like assess those questions. But just know kids might be like, well, I could explain this 2 different ways. And that's actually right. The idea here is that we want them to pick a particular way of looking at that question and then just back it up with that evidence and that reasoning. Okay, there are no new words in this unit, so nothing to do in terms of the word wall. We do have a poster that we create. That's that big ideas poster. It might be helpful for future lessons. There is one more assessment later on in the unit, so you may want to save it. That's up to you. And that's going to do it for lesson 10. Come back and join us for lesson 11. I hope this was useful to see how the students are really going to take all of those ideas, put them all together, and really feel some satisfaction that they can explain those original stories and explain a lot of things related to the game of baseball. Come back and join us for the next video. Lesson 11, we are actually going to re-anchor. So the unit takes a turn here, and the next lesson set is actually where we get into the engineering component of this, and we start to think about, now that we know how things get damaged, can we do something to protect them? Thanks, everybody, and we'll see you soon.